everyone, how are you all? I am Siddharth Kumar Jha, and today I welcome you in the Digital Image Processing lecture series. In the last video, we have explored the sampling and quantization, how continuous real-world images are converted into a grid of pixels with specific intensity labels. So now an important question is like once an image is digitalized, how it is actually stored inside the computer. Okay. So in the today's lecture, we shall learn about representing the digital image, the formats, data structure, and how grayscale and color images are organized into the memory. Okay, so let's get started without wasting our time. So for that, I have to open as usual my notepad. So just hold a second. Let me open it. Okay, so just start. So let me make out our topic like what is digital image representation. Okay, so it is nothing but a digital image. A digital image is represented as a 2D matrix array, or you can say 2D matrix or array, okay, of pixels, okay, of pixel. So each pixels has a value that representing intensity or your color, which is RGB, okay. So the matrix is stored in the computer memory row by row, okay. So now let's talk about the gray image representation. So gray image representation. So what it is? So a gray label image is the single 2D array. So in this, the pixel range between the 0 to 225, 0 to 225, and sorry, 255. My bad. And here the 0 is your black color and 255 is your white color. Okay, so for an example, let's understand 4 cross 4 grayscale images. So how it can be look? So it can be look like something like this. It is just a matrix, and here 0, 128, 200, 255, like that. The value is stored 50, 20, 10, 90, 80, 60, 170, 180, and 150. And here 230, 240, 210. Okay. So this is how 4 cross 4 image can be represented. Your grayscale images is represented as a matrix. Okay. So now we will understand the binary image representation. Okay. So binary image representation. Representation. Okay. So in this, each pixel has only two values. Either it can be 0 and 1. So 0 I have told you like black and 1 is for white. Okay. So it is stored efficiently with 1 bit per pixel, which is your BBP. So BPP. Okay, and it often used in mix, text or simple object detection. Okay. So now we will understand the color image representation, which is your RGB model. Okay. So color image representation. representation, which is your RGB image. Okay, so a color image is represented as the three spectra of 2D arrays, which is called channels, which is your red channel, your green channel, and your blue channel. Okay, and each pixels combined of R, G, and B values. For example, it can be like 200, 180, and 50. Okay, so this is a reddish brown. Sorry, the reddish brown is 100, I think. 200, 100, and your 50. So it is your reddish brown. Okay, so for the storage, 8 bit per channel into 3 channels is equal to 24 bit per pixels. Okay, so in the storage, it is like 8 bit. If there is 8 bit per channel, so it will take 8 bit per channel, and there is 3, so it will be 24 bit per pixel. Okay, and the called true color representation. So it it almost like 16.7 million colors. Okay, so let me show you the visualization of this. So just hold a second. Okay, so you can see here what I was talking about. So all three channels. So the first one is your red channel, and the second one or the middle one is your green channel, and the last one is your blue channel. So this is the channel, and using this our RGB image is formed. Okay, so let's move further with the memory layout. Okay, so let me write it down. Your memory layout. Okay, so in this image is stored row by row in the memory, and it is restart scan order. Okay, so you can write like image stored row by row in memory memory, and which is raster scan order. Okay, so for example, is there if there is a 512 into 512 a grayscale image, so how many pixels are there? So 2,62,144 pixels are there. And if it is 8 bits per pixel, then almost 2,62,144. And if there is like 24, then it is almost 786 KB. Okay, so let's move further. The other representation, like which is your, so the first thing is your index image. So it stored a color map uh, plus your indices instead of the full RGB values. Okay, and the compressed format is your like JPG, PNG, BMP, etc. that reduce the storage by its compression. So, okay, I have told you so many things. So let's understand its importance in the DIP. Okay, so the understanding representation is crucial for reducing and writing the image files and the reading of the email files and performing operations like matrix based, and it is efficient for the memory management. So just do a quick takeaway from the today's video. So it is the first point is like image are represented as the 2D array of pixels and binary grayscales, and color, which is your RGB, are the three main formats. Okay, RGB has three channels and each of like 8 bits and making 24 bit per pixels. Okay, and the memory requirement depend on the resolution and the bit per pixels. So I hope I am done with the topic. So that's all about the today's video. So in the next video, we shall discuss the spatial and the gray level resolution, the two key factors that control the image quality. So if this lecture helped you, so don't forget to like, share and subscribe to stay updated. Okay. So see you in the next video. Tab tak ke liye keep learning and keep exploring. Bye bye.